probability, addition rule and multiplication rule. The addition rule, definitions. P of A or B represent the probability of either event A or B or both to occur. Disjoint events. Events A and B are disjoints, or sometimes we call it mutually exclusive if they cannot occur at the same time. So for example, if event A is selecting someone who is a male, event B is choosing someone who is a female. Since we cannot get both a person to be male and female, then these events are disjoint. Now, these events here are not disjoints. Okay, because event A is saying select someone who is taking a statistics course, and event B is saying select someone who is a female. Well, because there is a female student who can take the course, and so we can have both a female who take the course, both female and both taking the course, and so it is a not disjoint event. It is critical because if event A and B are disjoints, then we have this formula. Okay, so P of A or B equal P of A plus P of B. If A and B are not disjoints, then P of A or B equal P of A plus P of B minus P of A and B. So it is critical that you know the events are disjoints or not. Okay, so let's look at this example. When rolling a dice, what is the probability of getting a 2 and a 5? Well, we know that we cannot get both 5 and 2 shows up, then we have disjoint events. And so P of 2 or 5 is P of 2 plus P of 5. Well, P of 2 is 1/6. P of 5 also 1/6. Right, because there are 6 numbers altogether and 2 shows up only once, so 1/6. Same with number 5. So 1/6 plus 1/6 is 2/6. Reduce that to the lowest term, it is 1/3. Here, when rolling a dice, what is the probability of getting an odd number and a 5? Well, we know that 5 is 5, but 5 is also an odd number. So we can have both 5 and odd number. Then it is a not disjoint event. So P of odd or 5 is P of odd plus P of 5 minus P of odd and 5. Well, since there are three numbers that are odd, then the probability of getting an odd number is 3, 6. Getting a 5 is 1/6. Here, since there's only one time that 5 shows up, and 5 is also an odd number, so the probability of getting an odd number and a 5 is just 1/6. So 3, 6 plus 1/6 minus 1/6 becomes 3, 6. Reduce that to the lowest term, it is 1/2. Now, let's talk about dependence events before we can talk about the multiplication rule. Okay, so two events are independent if the occurrence of one does not affect the other. If events are not independent, then they are dependent. Here's just some, actually, we have two notations here. Okay, so P of A and B is P of A in the first trial and B in the second trial. So these events occur in sequence. P of B minus or slash A represent the probability of B after it is assumed that A already occurred. Sometimes this is called the conditional probability. Okay, this is called the conditional probability. Because the event B occurred assuming that A is already occurred. So B to occur depending on the A. And so we have what we call conditional probability. Now, this is the multiplication rule. Okay. If A and B are independent events, then P of A and B is P of A times P of B minus A. Okay. If A and B are not independent, then P of A and B is just simply P of A times P of B. So once again, it is critical that you know if you have independence events. Let's look at some example. For this example, we have 50 test results from subjects who use drugs. So these are the results. 45 tested positive, 5 tested negative. So here is the question. If 2 of these 50 subjects are selected with replacements, what is the probability that the first person tested positive and the second person tested negative. And then we want to repeat the same process, but this time we select two subjects without replacements. Now with replacements, it just means that you get to repeat. Without replacements, you cannot get to repeat. So with replacements, first person, we want to be tested positive. So the 50 total, 45 test positive. So the probability of a positive test is 45 over 50. Second person, since there are 5 negative results, then the probability of a person testing negative is 5 out of 50. Now, because this is the idea of replacements, then we get to repeat the first person. So the original 50 people remain intact. Okay. So apply the rule, then we have the probability of first person is positive and second person is negative is then 45 over 50 times 5 over 50. Use your calculator, you will get 0.0900. Now with replacements, all it is just that we did not get to repeat. And so when you get to the second person, because the first person is already off the list, then we now have only 49 people left, and that's why it is out of 49. Okay, and because we still have 5 people that tested negative, and so the second person, the probability of getting the second person to be negative is 5 out of 49. Not 50, because once again, we don't get to repeat the first person. Okay, and so without replacements, then the probability of getting the first person to be positive and second person to be negative is the probability of getting the first person to be positive, which is 45 over 50, and then the probability of getting the second person to be negative, provided that first person is already tested positive, so therefore we don't have all 50 people left. We have one more short, and so 5 out of 49. So using your calculator, multiply it out, you get 0.0918. Now, just to be clear, the second person who tested negative here, 5 out of 49, is because we don't get to repeat the first person. And so we have only 49 people left.